It's my pleasure to introduce Hannah with SaaS-tainable security.
Yeah, so thank you all for coming to my talk on sustainable security, finding balance in a Kubernetes world. So what I'll be talking about today is we'll have a brief introduction about myself and A's, and then we'll jump into why companies and businesses are choosing Kubernetes and microservices to run their applications. I'll then go into the challenges and security risks that this brings, and then diving into securing development without hindering productivity. Then followed by cloud access and Kubernetes security best practices across the cloud, and then cloud and access security specifically to the stack that we use in Azure, and then some final takeaways around maintaining sustainable security. So I'll get started with a bit about myself. That is a huge photo, oh my God. So I graduated from Abertay in 2022 with a bachelor's in computing. I'm a DevOps engineer at A's and member of the CloudOps team, managing the cloud platform and infrastructure and optimizing that. I specialize in CI/CD, Terraform, and Kubernetes deployments using Flux for GitOps. So about A's and our product. So we are a company based in Norway with branches in Aberdeen and Houston in the US. A's is a leading SaaS software solution for collaboration and visualizing in the energy sector. It offers a digital twin platform to enhance capital projects and operations, allowing teams to visualize and navigate collaboration on digital representation of assets. In simpler terms, a digital version of a rig, say in the North Sea. So A's helps save time and improve efficiency and achieve organizational improvement targets. So I think it's important to have a kind of idea of what A's is about from the end user's perspective of what we're trying to secure. And my content team is a lot better at it than me. So here is a quick 50-second video of what A's does.
It's difficult to work and collaborate on large-scale projects when thousands of documents and collections of data are stored in different places. A's is a digital workspace collects all this information, making it easy to access out in the field or in your office. It's designed to help people build and operate complex facilities at scale. When data is accessible, everyone in the project can benefit from having a digital replica of the facility, all documentation at your fingertips, and the ability to collaborate with your partners in real time. View your model together and spend less time in meetings or going back and forth with email. In the energy sector, embracing digital workflows means increased efficiency and reduced cost. It's never been easier to have complete control in your industry.
So now you might be sitting there thinking, okay, that's great, but what are more of the nitty-gritty details, which I can provide far more insight into. So I'll start with why A's and other companies are choosing to use Kubernetes and microservices. So at A's, we've got one single app, and it's like a Swiss Army knife for an analogy for it. It has a basic version, and then you can add modules and features on top of that, letting you customize the app to do exactly what you need it to do. The back end is where all the magic happens, and it's packed with 34 services, all leading up to the front end. The foundation of our product is based in a cloud environment that can grow with you, and it's secure, reliable, and flexible, enabling us to scale to however many clients and customers and facilities that they require. So we're using 6 different programming languages across these services, and we have different teams working on each of them. So all of our developers have some knowledge in all 6 of these languages. There's 34 microservices across is that we deploy through GitLab CI/CD, and it is all on Azure Cloud Provider. So we've got multiple levels of security here. We've got from the customer environment into our cloud platform. We've got the cloud platform itself, and then we've got between the backend services back to Azure. And then, of course, we've got the backend services to the front end and vice versa. So I'll be concentrating mainly on the cloud platform and the backend front end services side of things today. And here is an image of Aza's cloud environment. So this is a handful of the services that we use in Azure. So you can see that we're fully invested in the cloud. We don't run anything hybrid or on-prem. And every tool is either cloud native or cloud-based. Now, why did we go all in on the cloud? There's a few reasons. There's scalability. We can easily scale up and down the services and our applications as and when we need more, say, storage. And the flexibility environment gives us agility, so we can move fast and iterate quickly for our development teams. The infrastructure is also rock solid on a reliability side of things. With redundancy and failover built into Azure, we are taking that off of our responsibility and moving it on to Microsoft. Now, there's a few things that we use outside of Azure, specifically GitLab for code management and Snyk for vulnerability scanning in our pipelines. And you might be thinking, why wouldn't you use Azure's offerings for this? And that brings me to my first point on security being a balancing act between your development teams and your op teams. It wasn't an ops team or a security team choice to make. We were given the design choice and the tool choice by the developers, and we then had to secure their choice. At the end of the day, it's what best fits for them. It was their workflows, their what they needed and wanted. And you have to find that compromising balance between security and what's easy and what the developers might want. So our Kubernetes journey, as I said, we've always been in the cloud. So we've always run our services on Kubernetes, but we've had a few hiccups along the way of different ways to deploy things. So we started with creating raw customization files, and these are just straightforward customization and YAML files that define resources like deployments, config maps, services. At this stage, it was a manual process of deployment. We would write and apply these directly to our clusters, ensuring everything was in place by hand. And as we grew, it became cumbersome to manage, and especially as complexity grew when we introduced more microservices. So we then moved into writing a Helm chart per service. So these streamline the process. We were then able to manage and version these rollouts, and you could use the same Helm chart for multiple environments or multiple like microservices with different value files getting called into them. We were then also able to use GitLab CI to then write jobs to deploy these Helm charts into Helm releases. Fast forwarding to today, we embrace Flux for our GitOps way of deployment. With Flux, our desired state of the cluster is stored fully in Git, and Flux just runs a continuous sync for any changes and any updates that it needs to deploy. So now we only have to look as if Flux has had an issue, then we have to get involved. Otherwise, everything just works without any manual intervenience. So moving on to growing the popularity of Kubernetes and microservices. So as technologies evolved, so has the way that we build and manage our applications. The recent shift in microservices and Kubernetes are transforming the way we architect and deploy modern applications. If you've done any form of certification on Microsoft or AWS, you'll see if there is a study guide from 3 years ago, it's all VM deployments, and now they're all being updated to have some form of Kubernetes information in them. So there's some statistics that I've gathered. So we've got in 2022, IBM released a study that found that 70% of organizations are adopting microservices for faster development cycles and greater scalabilities as their primary reasons for the shift. In 2023, Puppet's State of DevOps report showed a 47% increase to a total of 57% from 2020 of organizations adopting microservices in some form of capacity. And in 2023, the Cloud Native Computing Foundation survey found that 96% of respondents were using Kubernetes in some form of capacity. And that is an increase from 78% in 2020. So we can dive into why microservices have gained so much traction over the past few years. They've quickly become the new modern architecture, and it's all decoupling the services into smaller manageable services that can be handled separately, deployed separately, and grown separately. Microservices encourage the use of diverse technologies. They don't all need to be built using the same languages, same storage. Different teams can have different specialities. Additionally, resilience is a key benefit. Since services operate independently, a failure in one service won't bring down the entire application. Now, bringing Kubernetes into the picture, Kubernetes is an ideal platform for managing microservices. It's all about container orchestration, which means it automates the deployment and scaling and management of microservices so much easier than if you were to deploy them to any other platform. It's also a very platform agnostic tool. If you're running Kubernetes in Azure or AWS or GCP, they're all the same underlying. You might have to use slightly different commands to get into them, but Kubernetes across either hybrid, other clouds, or on-prem, it's all running the same way. So you've got consistency and portability no matter what kind of setup that you have. And scalability is where Kubernetes truly shines. It ensures that they can dynamically scale and the whole Kubernetes node and replicas of deployments are always up and can handle the traffic that you're serving. So some of the key challenges and security risks of doing this. I'll start with the biggest problem that we face at ACE. It's you're blocking me. If you are a student, you will either say this or hear it. I can put my entire life savings on that. And if you don't, I will be surprised. Somebody is always trying to get something done. And developers can sometimes feel like security or DevOps or any form of operations team is just standing in their way of getting the progress report that they need. They are just thinking about features or bug fixes, and they think that we're slowing them down and creating unnecessary roadblocks. And it might feel like that from their side of things, and it's not what we're trying to do. And it's trying to educate them to think of security first and the way that you're going to run it in production from the get-go. So our job is to guide developers towards doing things the right way the first time. We want to help them build secure software from the start, which means fewer headaches down the road. And the goal is quality and speed, and ensuring security is a crucial part of that equation. When we integrate security early in the process, we aren't hindering process, we're actually accelerating it. If you think of the times that you've had to get something so far down and then realize that there's a problem and then have to rework it, if that problem was found earlier, it would have saved manpower and lead to faster releases of that feature. So this is also another point of the balancing act. We're here to collaborate and not control, and we want to empower developers with the right tools and knowledge to build secure applications and try and educate that it's not a bottleneck, but a foundation for success. So some key security risks in Kubernetes as a whole. The first one is insecure configuration of Kubernetes RBAC. So Kubernetes use role-based access control, or RBAC for short, to control access to the Kubernetes API server. Misconfiguring RBAC can allow different users and privileged users or workloads more access than necessary. So if a user with admin privileges could access sensitive resources or manipulate cluster components if RBAC policies aren't configured properly using least privilege, attackers might exploit this and gain excessive control over the Kubernetes environment. And this could be from deleting workloads and deployments to tearing down nodes, having full control of nodes. So it can escalate quite quickly if you get access to that API server. And that takes me into point number 2, which is the API server. So this is the critical component of Kubernetes that handles all the requests for the cluster state itself. By default, AKS, which is Azure's Kubernetes service, restricts API access, but again, if it's not configured properly over permissive firewall rules or exposure to the API publicly, this can lead to attackers sending malicious requests or exploit to unpatched vulnerabilities. Ways of combating this is putting network policies in place and using private clusters in AKS and ensuring authentication via Entra ID are implemented. So the third one is vulnerabilities in the container images themselves. So if there is a workload in Kubernetes that's running that has known critical exploits, if somebody can get into that pod, they can then exploit that one to give itself more privilege and potentially take out other pods or workloads. Tools like Azure Defender for Cloud and container scanning can help detect vulnerabilities in these images. And you can also set it up to live scan your pods and deployments in production environments. The fourth one is improper secret management. So Kubernetes provides a secret resource for storing sensitive information, like API keys, tokens, and passwords. However, the secrets are only stored in base 64 encoded and not encrypted by default. So if these secrets are not handled with care, exposed in container environment variables, they can easily be retrieved and exploited. In AKS, you can use Azure Key Vault for better secret management. And instead of storing the secrets directly in the cluster, using Secret Store CSI driver linked up to dynamically fetch it from the Azure Key Vault. Then there's also unrestricted network access between pods. Kubernetes by default allows unrestricted communication between pods in the same namespace. So this lack of isolation, if one pod in that namespace becomes compromised, it can then access all the other pods in that same namespace. So to mitigate this, you can separate things into different namespaces and then have network policies across those to ensure only the necessary network connectivity between them is allowed. Then unpatched Kubernetes components and vulnerable AKS versions. Kubernetes is an extremely fast release cycle, and each new version typically contains security patches. So running older unpatched versions of Kubernetes can leave your cluster exposed to known vulnerabilities that malicious acts might take advantage of. You can keep up to date in AKS, but if you, for some reason, can't, if you've got resource limits misconfigured and nodes cannot restart, it will not update it because it would tear down your whole application. And if you become too far out of date, it will stop automatically doing it, and then you need manual intervention. And number 7 is pod security and privilege escalation. So pods in Kubernetes can run with elevated privileges in their security context is misconfigured. So if a pod runs as a root user rather than a container user, a attacker can access the underlying nodes and even escalate the root host system if compromised. So pod security policies or OPI gateway to enforce security standards and prevent pods from running in root and with non-root users can be applied. And the last point that I have on this one is lack of auditing and monitoring. So Kubernetes provides audit logging and monitoring capabilities, but these need to be explicitly enabled and configured. So any suspicious activities such as unauthorized API calls or privileged access in pods or a user connecting to the cluster wouldn't necessarily be seen and go unnoticed. So to configure this using either Azure monitoring or another tool to keep note of it and be able to see it. So I added this one in for like the developer challenges in a secure environment. We all have different challenges, and seeing the side from like the other side can sometimes be helpful. If somebody thinks that you're just here to annoy them and block them and not understand their problems, helping us understand their problems and then developers understanding security problems, we can come to a more common ground. So access control and permissions is obviously something that developers need to have given in certain scenarios. Like incident response, if your dev teams are the incident response, they need to be able to get into environments or logs without needing to phone you in the middle of the night as well to give them the access. Debugging and logging restriction, it also comes into this. If they can't see the logging data and sensitive information like user data or something would be hidden from developers, it has to be excluded from logs to avoid exposure and any log outputs. And troubleshooting can become more difficult if it is too strict. Network restrictions and firewalls, developers might need to connect to a bastion or a VPN to be able to see staging or production environments. That's another thing that they have to go through, and it can cause a frustration. There's also code scanning and security testing, static and dynamic analysis of it. We put in our CI/CD pipelines, but developers can also run it locally, so they don't go through all of their development and then end up with a red pipeline. So they can test it before they enter their merge request and then have to make a bunch of commits up into our GitLab. Security patches and updates is an ongoing challenge for developers. They must stay informed about vulnerabilities and the tools and the libraries that they use, and promptly apply any upgrades without breaking functionality or performance. The environment isolation also comes back into the debugging and access control. Different developers might have different access to different environments. You might have 3 environments, you might have 4 environments, and they can all be running slightly differently. So this can cause problems if there is a problem in one environment, but they can't be replicated in another one. It's then finding out what the differences between those are. So yeah, security patches and updates, keeping systems, including their Visual Studio Code, for example, up to date as well. I know we've all clicked the restart later button on our computers, and Visual Studio Code, it's getting in the way of our work. We don't want to do it right now, but it's important to keep the mindset of it's a security update. It's going to help you in the long run and protect you in the long run. Then we have the code reviews and collaboration hurdles. So collaborating on a secure environment or code can be challenging due to access policies and confidentiality. A data engineer might have more access than a regular developer that's just doing the front end code and trying to communicate between each other of what they need, because one can't see it, can be a hindrance over exposing sensitive data to people that don't need it or that you haven't signed off in your agreements with customers. And that's coming on to compliance requirements. Sometimes you need the likes of HIPAA in healthcare or GDPR. These regulations can dictate how your data is handled, who can access it, as well as client contracts. And the last two, we've got performance trade-offs. Security measures can sometimes mean that you lose a slight bit of performance, and developers have to carefully balance the need for encryption and secure authentication and other protective measures while still maintaining a fast and responsive application. And the last one there is security awareness training. Developers, if you put them through security awareness training, you normally get some grunts and grunts about it and, oh, it's cringy and all the rest of it, but eventually they will do it. And at least it puts it at the forefront of their mind. It might be something that they haven't thought about before that's in it. And then you do take away the time from them of developing their features. But it's then in the forefront of their mind and they're thinking, okay, maybe it's not a complete hindrance. This has made me think of a vulnerability in one of my libraries. So that brings me on to securing development without hindering productivity. And securing throughout development. So we don't want to just secure at the final step in production. We want to embed it throughout the entire software development lifecycle. So shift left security, involving integrating security practices early in development to identify and mitigate any risks as soon as possible. So developing secure code isn't only an operations problem, it's a shared responsibility across most departments. Each team has to understand how security impacts their role. You can apply the same principle to any other operations team as well. If everybody can understand the benefits, it goes a lot smoother. This can often lead to prioritization problems between features and tasks outside of the main focus of developers, and integrating into that planning cycle is important to make sure that they're not surprised by any requirements that security might have. So for local development, encouraging developers to follow secure coding standards, preventing vulnerabilities like SQL injections, cross-site scripting, using tools like static analysis, SonarQube to scan code locally for vulnerabilities as it's written. Ensure developers are using isolated secure environments like dev containers. It means that the app not only is going to be running the way it will in a production environment to mitigate the problem of it's working on my machine, but it's not working anywhere else. And testing new technologies and features locally with security considerations in mind to ensure they don't introduce any new vulnerabilities. And then in our CI, integrating those tools that they were running locally, like SAST and DAST scanning, to automatically check vulnerabilities as the code is integrated. We want to make CI using the tools that they're supposed to be rerunning locally, but if somebody missed anything, it's like a last minute check before anything went in. Incorporating unit tests and security focused unit tests earlier, ensuring vulnerabilities are caught earlier and before merging code into the main branch. and making sure that these checks are all run in a merge request process, and preventing a merge if any of them were to fail. Then in continuous deployment, implementing security gates in the deployment pipeline to prevent code with known vulnerabilities from being deployed, including the security static analysis and secret testing for both code and infrastructure as code, making sure no API keys or tokens or anything are exposed in the code. Monitoring and validating infrastructure as code configurations for any known security misconfigurations using tools like Terraform Validate, and ensuring security practices are followed when deploying to the likes of testing or staging or production. And then in the production environment, making sure to use intrusion detection system tools and security information and event management solutions to detect any suspicious activity, ensuring logs are securely stored and monitored for any sign of breach, regular scanning the production environment for any new emerging vulnerabilities of code that has already been deployed, and ensuring that there's robust processes in place for handling the likes of a security incident or a code or a data incident, and quick identification and containment of the breach. So going into a little bit more detail about the CI/CD pipeline security, here are some steps that we put in our CI/CD to enhance our security. So we've got, first up, we've got unit testing. So ensuring that code doesn't introduce any new vulnerabilities through any libraries at the individual unit level. Automated unit tests, validate logic and edge cases earlier in the development cycle. I've seen it many times where the unit test will be run locally, and then when it gets into the merge request, the unit tests fail. They're then screaming at you because it's working on my machine and it's not working in here. And you find out that they had Yarn cached and they didn't install any of the new packages, and the cache in the pipeline didn't, and it found the problems. There's then integration tests, so integrating between components, other APIs, other microservices, databases to catch any vulnerabilities or misconfigurations there. Then we run vulnerability scanning using Sneak, so continuously scanning the code, dependencies, and containers for any vulnerabilities of high or criticals before going forward with any deployments. For secret management, we use all of Azure Key Vaults to securely manage anything like API tokens and passwords and certificates, ensuring that they're not hard-coded into the code base. For CI/CD secrets required before runtime that cannot be dynamically fetched, we use GitLab CI/CD variables, which are the same as Kubernetes ones where they're base 64 encoded. And that avoids any exposure inside the pipeline logs themselves. And then across all repos, we've got applying security checks across all of our code repos, our IECs, our security configurations, and including the likes of policies as code, and any automated scans for misconfigurations in those. So now I'll talk about some of the best practices and some of the ones that we implement at A's. So for at A's, we leverage Azure RBAC for access control. So all users and service accounts, we utilize managed identities, so we don't have to manage service principal credential rotations. They're all governed by Azure role-based access and Kubernetes role-based access. We implement just-in-time and just-enough access principles to minimize any unnecessary privileges and reduce exposure to threats. As mentioned, we have security in our CI/CD pipeline, but we also use dedicated Kubernetes runners for our CI/CD in a secure CI cluster. We manage the update cycle and vulnerability scanning of these runners themselves to remain secure, and we avoid using shared runners provided by GitLab, as the storage of those job logs are not stored by yourself. You're trusting GitLab with them, and if you accidentally expose something, the default answer is it's compromised and you need to rotate it. We have environment control and deployment, so only upper environments can be they can't be touched manually. Only pipeline and GitOps workflows are authorized to deploy to upper environments, ensuring we've got full auditability and reducing human error in these environments. To try and balance security and developer experience, we provide developers a sandbox environment to manually test and experiment with resources, and then to promote security and consistency. Once they are happy with their services or a new Azure service that they're going to use, to merge the code into develop on higher environments, it must go through infrastructure as code and code deployment pipelines. And then we have pod security, and no pod is granted root access, ensuring strict access control and minimizing security risks once deployed. For RBAC and least privilege, all security principles that we use, so user service principles, workload IDs, all follow using role-based access to control their access within the cluster, ensuring only authorized users and service accounts can perform very specific actions. We follow the least privilege principle by granting users and service principals only the privilege that they require, minimizing the potential of a compromised account being able to cross over onto other workloads in our clusters. All of them are done through Azure RBAC and limiting access to sensitive resources, and ensuring that no user or service has access to something that they might not need at the end of the day. We've got audit logging enabled on all of our clusters to monitor and track user actions and service account actions, ensuring nothing deviates from any of our access policies. And we're also utilizing namespace segmentation, as I mentioned before, to isolate workloads and enforce more granular RBAC policies and network policies across our environments. Going into network policies and pod security, we implement network policies to restrict traffic between pods and services, to control ingress and egress, limiting access to only necessary components. Not all of the APIs need to be able to talk to each other, and it's ensuring that only the ones that do need to talk to each other can. Pod security rule policies are enforced, restricting root access, privileged containers, and enforcing pod security rules, or the now enforced pod security admission rules to minimize attack surfaces. For the restricting traffic, it ties back into the network policies, limiting communication between pods to only what's needed, and enforcing those policies across different environments, and centralizing it and keeping it as easy as possible using OPA and Gatekeeper, so we're not manually having to do this in each one. So I'll now cover some of the Azure features that we use for cloud security and their access solutions offerings that we use at ACE. So the Azure security measures, we've got Azure policies, so they help us automate governance at scale by creating and assigning policies. You can enforce standards across all environments, all subscriptions, and it's a lot easier than manually doing it for, say, each key vault that's in use. You can tie these back to compliance standards, ensuring that any compliance that your company has to abide by, whether that be ISO or GDPR or HIPAA in healthcare, you can know what is being covered and what is not. They automatically apply to security configurations the minute that you put it in place. You can put it on a warning level so it doesn't block anything if you think that it will. You can have them from as simple as inheriting a tag from the resource group if it doesn't have one, to blocking access. We then use Azure Defender for Cloud, which previously known as Security Center, and this provides us comprehensive protection across our entire cloud environment. It also includes multi-cloud and hybrid infrastructure if you have it, and we utilize the security posture management Defender for containers, primarily to stay ahead of any problems that we may face in our environments. And we also use Azure monitoring for continuous monitoring and logging, and real-time alerts and insights. What's great about Azure monitoring is we can integrate tools like Azure Automation and Logic Apps, meaning you can set up automated workflows to respond to security incidents or create the security incident if that is the automation that you're looking for. On that, we use this for a security point of view, but the developers also use Grafana and Grafana incidents for application logs and monitoring. So in our Azure network, we use a VNet hub and spoke architecture. So this topology offers a centralized, scalable network to this design for enterprises. It's used quite a lot in hybrid environments as well. The hub serves as a central point for any shared services like firewalls. These services also tend to be the more expensive ones that you don't want to have deployed multiple times. The improves performance with routing wise through VNet peering, and provides connectivity between the spokes, making it ideal for centralized networking and security. It utilizes private endpoints for database servers and key vaults, for example, making sure nothing gets translated over the public internet. It all goes through Azure backbone for connecting. There's then the Azure Application Gateway, which we have implemented with Web Application Firewall. And it provides essential protection for applications by filtering and monitoring your HTTP traffic. These are used for the most common exploits such as SQL injection and cross-site scripting, keeping your application safe from malicious traffic. The application gateway also functions as a load balancer, distributing traffic to backend services across multiple regions or availability zones, ensuring you maintain high availability of your production assets. It can also handle SSL and TSL termination, managing the decryption and encryption of traffic. By offloading this task from the backend servers, it's then raising it up a level to stop your traffic getting as close to the application as possible. We then have a site-to-site VPN for lower environments, and this is to provide secure and encrypted communication between our on-premise laptops and our developers working from home, to our dev Azure network for the likes of databases or Kubernetes if they need to investigate anything inside of it. Then for our upper environments, we use Bastion hosts. So these allow you to securely access virtual machines as a jump host, which are hosted in the hub and then connected to the spoke of the region that you're trying to connect to. This eliminates any risks on your host machine being infected by anything and then going through your VPN. And we then only have to manage the jump host security and any vulnerabilities on that to keep it up to date. This is also used with just-in-time access, so we restrict it to only when an incident happens and you need to connect to it. You can then activate your just-in-time and then you can connect to the Bastion host to look into the problem. We utilize Azure Identity Governance through My Access. So it's a self-service resource access and app enrollment. So we enable teams, whether it be developers, non-technical staff, other op teams, to request access to resources and applications through predefined My Access packages. So every data engineer is going to need a set of applications and access. They can request that without needing to go to IT. If you are a DevOps engineer, you're going to need a different set of access, and you can also request that access package without needing any IT involvement. It then just has a preset defined approvers that can grant you this access, and it takes out any backlog queue waiting for IT. So they are pre-configured access packages with the package length and expiration, whether it needs approvals, 2 approvals, 5 approvals, and how long it will last for, and if it's going to go through access review. So one example of something that would never go through an access review would be the HR system. If you're employed, you're going to need to have access to it. So each one is individually assessed through a process, which is then documented so anybody can see what kind of packages they'll be able to get. So it also provides, as outside of resources and app enrollment, you can also create custom groups based access and visibility. So you can have it that anybody can access these set of groups, say a developer package that's just a base package. Then once you're in that package, you can then see if you, a data engineer package and a DevOps package. So we try and make it as hierarchical as possible, and only what you can see is what you should be able to see. And then we have that it is all done through infrastructure as code. It's fully managed in Terraforms, and teams like CloudOps or Securi-Tay or IT can all edit these and collaborate and define and maintain any additional ones that come up. It also allows us to automate it, so none of us need to have privileged access roles to be able to create it, and it can then be versioned and get if something goes wrong with it. We then have a privileged identity management, PIM in Azure, and this is for more Azure-based elevated privileges rather than the My Access one, which is privileges that you're always going to need. So this is where we use our just-in-time for a temporary elevation of access. So this is a limited period such as hours or days, and it automatically expires, unlike My Access. There's special logging and auditing with PIM. If you PIM yourself, everything in your Azure account gets logged, whether the services you're accessing or not have logging and enabled or not. So you can see everything you did when you were PIM. So if it needs to be reviewed for any reason, it is all there and can be exported and presented. It can be used with Azure resources and Entra ID integration. So the likes of identity governance or general admin can all be used, as well as Azure security groups made by itself. And we also automate this via infrastructure as code. The same as my access. Anybody can go and add a PIM role, and then it goes through the pipeline of approval process. And yeah, lastly is my final takeaways. I've got security is everyone's responsibility. While security might not be our primary role, we all play a part in it. For example, a subject matter expert, you might have to bridge the gap between your knowledge and your security team's knowledge, helping them understand the new technologies so they can then go and investigate best practices for how to implement security. Collaboration is a key. Developers need to think about security in addition to features and bug fixes, and it is a balancing act between giving them access to build and innovate while ensuring security isn't compromised, and finding solutions that don't hinder either person's development or progress. Empathy across teams. Security teams should recognize the challenges developers may face, same as developers understanding the challenges security may face. Balancing these measures with ease of development should be a joint effort and make sure the job gets done without any unnecessary friction. And then the evolving security landscape with Kubernetes. As cloud computing continues to evolve, so do the security challenges. With Kubernetes enabling greater scalability and flexibility, new security risks emerge. Kubernetes environments are complex and dynamic and require vigilant monitoring and secure configurations. And focusing on managing these risks in containerized environments is essential to any company's progress in the Kubernetes world. And that's all I have. Does anybody have any questions? Yeah. Yeah. Yeah, so each microservice has its own service account in each environment. So the dev, say you've got service X, the dev service X service account will only have access to what it needs in dev, whereas it will have a different one for production. Yeah. It's not hard to manage if you've got everything in Terraform and modules. We basically just have to write one line of code with the name of it, and then everything gets assigned out of it. And then as you build your key vaults or your databases, you then just have to reference that account. So yeah, having your Terraform organized does help. Yeah.
Thanks for this. It was very thorough. When you had your kind of 8-pointed star of Kubernetes security concerns,
Yep.
It seems to me like a ton of those can be solved by providing a good default secure configuration, like your intrapod network security, the patching and all those sorts of things. Is that how you approach it, or do the dev teams do what they want to do and then you go back and tell them, oh, you did that wrong?
Yeah, so we have our defaults in our Kubernetes. Those ones that I put on are mainly the ones that you have to think about. So you don't have them by default in Azure. You have to go take the initiative and realize, oh wait, that's a problem. We need to go implement network security policies. When you spin up an AKS cluster, it's not going to provide that for you. So it's something that cloud ops and security had to then go manage. And then with using local development for dev containers, they then learn about those network policies before you get there. So when they're like, my API can't hit this other API call, and you're like, okay, well, how are you getting to it? And they're like, oh, well, I'm going outside the cluster, and then I'm going to come back in using its public endpoint instead of just going through it. Yeah. Oh.
When you were saying that when you're running multiple deployments, I'm not too sure how Defender for Cloud runs with the sidecar or how exactly. You were saying that you test performance locally as much as you can. How do you implement that with security like Defender for Cloud? Run that locally? How do you
Yeah. So we use as much tools as we possibly can using locally. So we'll provide the configuration for the dev container in VS Code, and then have the likes of Sneak installed on it. So the developers don't actually need to install anything on their computers. And then all of those other tools that we use are then linked back to Defender for Cloud. So our Defender for Cloud can read everything that gets into put into Sneak, and our users can use Sneak locally. Yeah.
I was curious how you, with the vulnerability
Mm. So we don't have a zero policy for anything blocking it. So we have anything that's high or medium gets immediately blocked, and then a low one will have a window in which it needs to be dealt with by the dev teams. And then if they haven't fixed it, somebody then goes and yells at them to tell them to go fix it quicker. Yeah. So they'll get notified, and we'll notify them as well to get them to do it the most. Some of our Sneak obviously runs might run fine one day, and then we're going through a release process, and then all of a sudden it's then broken. So then there's more cross team collaboration to get the release out to get it fixed quicker. Yeah.
How does the pipeline progress work inside or trying to escalate?
Yeah, so it's based on approval and justification. So when anybody PIMs, depending on the PIM, somebody will immediately get notified that somebody has triggered it. And then it's given to you based on your like role. So only certain people already have it. So you already know there'll be like, say, 6 people can access this. And then you go through, before you give them the PIM, the approval process of it. So yeah, it's more monitoring, like when it gets triggered, their justification for it. You can add an approval on it as well. We don't use that for our one. We just do the justification and the email. But you could add more approvals on it to make sure they definitely were doing something that they should be doing.
Well, I think we're going to have to call it
yeah.
just because it's come past 12.